Hello and welcome to Elementary Algebra. How are you all doing? Yay! Great. Are you excited? Awesome. The goal for today is to review a couple of problems from 3.1 and then see how far we can get with chapter 2. Let's see. I hope homework is going well for most of you, some of you, I don't know. We'll see. This is the first class that has been on the live stream in terms of YouTube, so you will be able to review this lecture at a later time. I'm currently logging in on a different computer to make sure that the whole thing is going, and it is. I will just check the sound, and after that we can start. Perfect. So everything is up and running. So from this point on, you will be able to type my full name, good luck with that, in YouTube, find my channel, and find these lectures over there. Then you will be able to review for your exams and rewatch stuff if you haven't caught it the first time when it was done. Now you all see the screen where I write. Is that correct? Awesome. Let's take a look at few exercises. So this is going to be a short review of 2.1 problems, just to get the blood pumping, start the day. How about x plus 9 equals negative 7? What should we do? Get x by itself. Awesome. How do we achieve x by itself? Awesome. Subtract 9 from each side. That will kill off the 9 on the left. And what happens with the solution? Number is negative 16. Good. Right. And then we can check. Now guys, if the problem on the exam says solve and check, check gives the points. So you have to do it. You should always do the check because, let's say you care and you want to know that you did the problem correctly, you should always do the check. But if the problem says solve, then check does not give points, even though you should do it. But if the problem says solve and check, then check is mandatory and you should always do it. So in our case, we have negative 16 plus 9 should be negative 7, and that's negative 7 equal negative 7. Since we reached the correct statement at the end, you are okay to box this as a solution. Let's see something else. How about 1 equals 1/3 plus y? What should we do in this case? Yes, move the fraction over, which means we are subtracting 1/3 on both sides because we have positive 1/3 on this side, and to remove it using what we call the additive inverse, right? Use the same number with the opposite sign, then they cancel, and we have to compute 1 minus 1/3. Now how do we do that? Did I hear common denominator? Okay. So 3 over 3 minus 1 over 3, which is 2/3. So we'll say y equals 2/3. 1 can be written as 3 over 3 and 4 over 4 and 10 over 10 and 100 over 100. So you can always write a whole number as a fraction if you need to solve something. Now to check, we simply say, is 1 equal to 1/3 plus 2/3? And the answer is yes, because you will get 1 equals to 1, because 1/3 plus 2/3 is going to be 3/3. Great. I will put another problem. This is something. Ooh. Let's see this one. 0.5t equals 3.5. I have to go get the cooling pack for the tablet again because it is already overheating. I have been using it. So I'll put 2 problems up and you guys work on them, and I will be back in 2 seconds. This one is 2.2t equals, this is when it starts overheating, it's having issues, negative 9.9. All right, go. Right, one heating, actually cooling pad installed. You still there? Wow, I am honored. You haven't heard professors go, "Oh, you still here? Aw, I was hoping there'd be no one in by the time I come back." So yeah, only in my class. What do we do for the first problem on the left? There is a solution. I'm sorry? But it's multiplication. Okay. The sound is really getting... All right, so here we go. Divide both sides by 0.5, and when it cancels on the left, we have t equals 3.5 divided by 0.5. We're not cooled off yet, so it's still issues. No. All right, let's see. I accidentally shut off the tablet, but everything is back. All right, so We divide both sides by 0.5 because we have to do the opposite operation. Always to get the variable by itself, to get the variable alone, you have to divide. In this case, you have to divide because that's opposite from multiplication, that it's between 0.5 and t. So we are going to divide both sides by 0.5, and the answer is 7. We can quickly get to that answer by multiplying both numbers by 10. And if we multiply both numbers by 10, we would get 35. Wow. Tablet is overheating so much that even the cooling pad is not catching up. Now let's try this. So 35 over 5, and that's equal to 7. Now, much better way of dealing with this problem is to write it in as fractions. So you would say 1/2 t is equal to 3.5 is 7/2, because 3.5 is half of 7. And remember that fractions are just a basic division. So you can write 3.5 as half of 7. And now, if you multiply both sides by 2, because that's how you would cancel this denominator on the left to get t alone, what happens on the right-hand side, they also cancel. And you just get 7 instantly. So this is one of the examples where we see how well we can work with fractions, and that they get to be a little bit easier than decimals when it comes to computation, because with computation you actually have to use the numbers you have. In our case was 35 and 5, but with fractions, as you can see, we only cancel the 2 and we are done. The same will happen in the other problem. You still have a multiplication here, so you are supposed to divide. Let's see what you guys get. What should I do on the right-hand side? I mean, to solve the problem. Excellent. Divide both sides by 2.2. So on the left-hand side, that just cancels, leaving a variable t alone. That could be t, could be x, could be y, could be z, could be any letter we pick as our variable. Now on the right hand side, if I multiply both numbers by 10 to get rid of the decimals, we get negative 99 over 22. And I hope that you see cancellation here, because both numbers are divisible by what value? 11. Very good, very good. So the answer ends up being negative 9/2, which is really, really cool, in my never humble opinion. Okay. Now we are going to start looking at problems that are going to have addition, multiplication, and subtraction, all of this stuff combined in one problem. So far, all of these problems were one step. You do one opposite operation and you are done. But now we're going to take a look at multiple operations. So now when I'm starting my section 2.2 on linear equations, which we are later on going to graph and learn a little bit about the slope and things that will be, I believe, in chapter 3. Now we are just going to take a look at a linear equation in one variable, which is of the form, I'll write that as a definition of ax plus b equals to 0, where a is not allowed to be 0, otherwise you would kill the variable and you would just have, number b equal to 0, which would force b to be 0, and there's no equation there. So this would be linear equations, and a and b are constants, and x is a variable. And the value of that variable will always depend on numbers a and b. Now, guys, this is going to later turn into your linear line y equal mx plus b, which this is already technically mx plus b, as you can see. This will turn into y equal mx plus b, and you can use that to calculate a lot of cool stuff. So more about that when we get there. Today is more about calculations, more about figuring out order of operations and all of these things. So let's say that we have an equation that says 3x plus 12 equals to 0. And we want to solve for x. We want to solve for x. How do we achieve that in this case? Excellent. We are going to subtract 12, and then we're going to deal with the 3, and then x will be alone. So from this point on in your journey in mathematics, until you're done, equation is always having one goal: get the variable alone, right? And if you have multiple variables of the same kind, put them all in a pile first, and then get it alone. We'll see some of that, previews of that as well in this course later on. So our goal is to solve for x, which means I have to kill off these numbers 3 and 12. Now, which one goes first? Which one goes second? You can use Pemdas backwards to determine which one to remove first. Now, since some of you already know what you're supposed to do, I'm going to solve this problem, and then I'm going to explain the order of operation and all of the other things that we have. So negative 12 on both sides. That's our first step. That will eliminate 12 and leave us with 3x equals to negative 12, because 0 minus 12 is negative 12. Once I have this done, to get x alone, the next step is to divide both sides by 3, and I'm going to get x equals negative 4. Now that should be my solution, and I can check by plugging in 3 times negative 4 plus 12 is that 0. 3 times negative 4 is negative 12, plus 12 is equal to 0. 0 equals 0. It's a true statement. Therefore, we have correct statement. Now, there we go. If I don't make it through the class, just remember solving equations means get x by itself. All right. So now we talk about Pemdas, and we talk about the order of operations. We talk about solving equations in general when they have more steps than just one step, which is what we had in 2.1. I'm going to write Pemdas differently than you are used to. I invented this. And the reason why I write it this way is I want to emphasize that multiplication and division are of the same category, same weight. And they should be dealt with as you get to them, reading from left to right. And same for addition and subtraction. So parentheses will always be first. And then exponents. Those are the guys 3 squared equals 9. Actually, let's write the whole thing. 3 squared is equal to 3 times 3 equals to 9. So exponents. Then you have your multiplication, division, whatever is first. And then you have your addition and subtraction, again, whatever is first. So that's the PEMDAS. And order of operations are there to compute expressions. So we use it to compute mathematical expressions. So if I have a mess, like 3 open parenthesis x plus, now let's not use let's just go 4 squared minus 9 plus 12 divided by 6, whatever. So you just have this expression. Now this stuff is in your previous course, and it's designed, I mean, this is complete garbage. There is no application to this line. I mean, maybe if you think really hard, you can come up with something, but you would be thinking harder to figure out how to use this in a real situation than to actually solve it. So we want to use PEMDAS here to compute these values. So where do we start? Parentheses first. Okay, well, I have parentheses here, but I need to compute the stuff that is inside. And inside I have a subtraction and I have exponents. So the first step would be to calculate 4 squared, which is 4 times 4, which is 16. And then we will deal with the rest. So now when you look at this expression, it has multiplication, has parentheses, has subtraction, addition, division, right? Has a whole bunch of these things. So you do have parentheses. Remember, PEMDAS. So we're going to compute 16 minus 9, and that's going to give us 7. And now 3 times 7 is 21, plus 12 divided by 6 is 2, for a total of 23. So this is the way to use PEMDAS. You always look at the expression. You figure out where your parentheses, exponents, and what operation is supposed to be taken care of next, because, right, there is the order in which we have to compute this in order for the expression to get us the correct answer at the end. Now, as I said, this problem is usually never this complicated, but our equations are much simpler than this. And PEMDAS for equations is used backwards. Because remember, for equations, you are not computing forward. You are taking stuff away to dig and get x alone. So it's reverse PEMDAS that you would use for equations. And that's how we know what gets removed first, what gets removed second, and so on. So if I have an equation. So, switch here. Equations would use reversed Pemdas. So, Pemdas like this. Because we are removing terms, meaning we are going backwards. So when you have expression, you would use Pemdas the regular way and compute the expression. If you're solving equations, you are technically going backwards because you are removing terms to get x alone. Therefore, it should be common sense, right, to use Pemdas backwards in that case. So if I go to an example from textbook here, now this one doesn't have a 0 on the other end, which is okay. Something like this. And again, it's always solve for x. We can employ our backwards Pemdas to get x alone. So we locate x, there it is, and we know that we need to remove negative 5 and we need to remove positive 4. Now 4 is added and negative 5 is multiplied. So when you look at your reverse Pemdas for solving equations, you see that addition and subtraction need to be dealt with first. Well, I have this plus 4, which is why we are removing 4 first. And once that is done, we will have negative 5x equals negative 1. And now the only thing that it's in a way is this negative 5, which is again multiplied. So, because it's multiplied, we have to divide both sides by negative 5. And once they cancel on the left, you will get x alone, which is what we are looking for. And on the right hand side, the negatives will cancel and we'll just get 1/5. Those of you in love with decimals might write 0.2. My MATLAB might or might not accept that answer because fractions are superior. You'll have to deal with that. You'll have to deal with that piece of knowledge now that fractions are superior. All right. And for exam, I really don't care whether you put 1/5 or 0.2, but your homework software might. So it's, try to leave it as a fraction if it's a fraction. Now, if it's a fraction that you need to cancel and reduce, right, then you do that. All right, let's take a look at couple of more of these, and then we're going to take a look at some computation as well. So I'm just going to jump into the homework and see if we can get some of these solutions. And there will be some spicier cases as well. We'll see that as well. Let's go and start with problem 36, which says 31 is equal to negative 7x minus 4. All right, so I'll give you some time to figure that thing out. Any suggestion on what should I remove first and how? Awesome. So we add 4 to each side, which will eliminate addition, right? Looking at the backwards Pemdas. So we dealt with the subtraction there. And 31 plus 4 is 35. And then last operation is? Awesome. And the answer is? Perfect. So we are going to write this as x equal -5. And now, since I care, 31, is that the same as -7 times -5 minus 4? So 31, that's negative times negative is positive, 35 minus 4. 31 equals 31. Woohoo! So when you do the check, you absolutely have to get the same number. If you're not getting the same number on the bottom, that means, I mean left and right, right? That means that your solution is most likely incorrect, and you need to redo it. I mean, given that you computed correctly in the check. There have been plenty of cases where the student solved the equation correctly, plugs it in a check, gets the check wrong, and then goes back and changes the correct answer into wrong one. There has been plenty of that as well. Let's take a look at slightly spicier case. Problem 38 is going to have a z minus 5 on the left and 5z minus 3 on the right. Does anyone remember what I said about, I don't know, 0.5 minutes ago regarding having multiple x's? What should we do? We don't solve them separately. It's one equation. They're connected with the equal sign, so we have to keep them together. Well, yes, eventually we are going to subtract z or subtract 5z or so on. We have to pile up the variables. Guys, that's very important. So in order to solve this problem, you are allowed to have at most one variable, in this case z, in the entire problem. I have two. I have z on the left and 5z on the right. And that's no bueno, right? So what I have to do is I have to put those z's on the pile, and I can do it in any way I want. I can subtract z on both sides, or I can subtract 5z on both sides. It doesn't matter. What matters is to put these z's on a pile. Once you have the z's on the pile, you will see that the problem transformed into the problem we did before, where you move the number, divide by a number, and you're done. So the first order of business is to either subtract z on both sides or to subtract 5z on both sides. Now, you correctly suggested to subtract z. It's better because if you subtract 5z on both sides, you are going to get negative numbers for, no reason, where you can just work with positive. So once I subtract the z on both sides, I get -5 is equal to 4z minus 3. And this is the problem we had in our previous example, where it should be clear what to do, right? What should we do? Five apples minus apple is? Yes. Woohoo. Exactly. Eat one apple at a time. Don't be like me. It's a 1z. Yes. It's a single z. And then you have 5 z's and then a single z. So, yes, so 5 z's minus a single z gives us 4 z's. Good. Yes. I'm wondering how many of you are already going zzz. Because it's that time of the day. I mean, maybe you had food already. It's, you know, nice and dark. It's gloomy. It's terrible outside. It's humid. And probably half are already counting z's. Because we've been, you know. I know. I stand by this. Algebra is the most, by far, the most boring class of all math courses I have ever seen. I've seen a lot of them, but by far, right, if I have to crown one class as the most boring class in mathematics, it's going to be algebra. And I understand when you pass out. I would pass out too. I can't, but I probably would. All right. So now we have -5 equals 4z minus 3. And what am I supposed to do now? Perfect. So we get rid of that number. We are digging in to get z alone. How much is -5 plus 3? -2, correct. That's going to be 4z. And now what I do to get z alone? Divide by 4. So we have -2/4 equal to z. Can I make this -2/4 better? Excellent. Divide both numbers by 2 and get -1/2. And what we're going to do now? Yes, we're going to plug in this fraction and see. Ooh, that was a nice creak right there. No. Oh, I was hoping that was. No. I was hoping it's one of those coffins, and then the Dracula is going to come up. But because it's already time, you know, it's dark and everything. But well, it has to start with good evening, and then, you know. All right, I have the accent for it. So we have 1/2 minus 5. That should be the same as 5 times 1/2 minus 3. So hopefully left side equals the right side, and we can call it a day. I mean, call it a problem. We have other problems to solve. So, how do I deal with 1/2 minus 5? I'm actually going to move this so we have more room. Do this in your notebook. Yes. Yeah, you have to do the same thing on both sides, yes. Mm-hmm. It's a -1/2, yes. Oh, you mean when I plug things in? Yes, I was just testing you, and everyone but you failed the test. Very good, very good. We plug in -1/2 everywhere. Correct. Okay. So, when you are supposed to add or subtract a fraction and a whole number, you can make a whole number into a fraction by placing on over 1. For common denominator, we are going to multiply by 2 top and bottom, because the common denominator would be 2 in this case. And we are going to get 2 as a common denominator, -1 minus 10. because the numerator on the second number is -5 times 2. Why is it times 2? It's times 2 because you have to get the common denominator of 2 for the problem. Now that should be equal to, and on the other side we have multiplication here. Now multiplication just goes across. I don't need any common denominators there. I still have 5 over 1. When I go across, this just becomes -5 halves. And I still have minus 3 over 1. Right, there we go. So anytime when you are combining a fraction with a whole number, make sure you put the whole number over 1. Because, oh now my chair creaks. So anytime you're combining a fraction with a whole number, make sure you put the whole number over 1, and then that makes that whole number a fraction. And then you can go on with the common denominator and everything else that you can use, that you need to use to solve the problem. So on the left-hand side, we are technically done because we just have -11 over 2. And the right-hand side now needs our common denominator of times 2. And we see the common denominator is 2. That's -5 minus 6. -3 times 2 is -6. And finally, -11 over 2 equals -11 over 2. Yay! Which means that our solution we had before was correct. It is -1/2. So -1/2 is a correct solution. So a little bit harder to check when you have fractions around, but it's not impossible. And obviously by practicing fractions, you always get better and better and better. So that means you will be able to compute these things faster. Let's take a look. More examples. This is just examples, examples, examples. And then you keep practicing. Let's try problem 4. X minus 1 equals to 5. This is problem 41 in the textbook if you care. What do you suppose we could do here? Okay, that's one of the ways. Perfect. We can do that. So distribute the 4. And what do we get? Beautiful. Equals to 5. Now what? Add 4. Yes, opposite, right? Because it was minus. All good. So, what should we do next? Oops. 5 plus 4 is 9. What should we do next? Excellent. No, that's perfect. You guys should talk over each other. It would be great. The more chaos, the better I like it. That means that everyone is participating and fighting for that piece of bread. Or the fame, in this case. Anyway, there it is. 9 quarters. 9 quarters is our solution in this case. Now, what I'm going to do here on the side is the other way. Let's go orange. Way 2. So, what I can do, since this 4 multiplies the entire left side, I can just divide both sides by 4 immediately, and that will kill off the 4 on the left, and there will be no distribution. And you get your 5 quarters on the right. Now, I'm going to add 1 to both sides, and I have x alone. X is equal to 5 quarters plus 1, which is 5 quarters plus 4 over 4. X equals 9 over 4. Are we all good with this? I know 2 people are out of 17. Anyone else, please? Should we do the sleep check and see who's listening and who's sleeping or AFK or? Oh, you think you're gonna wake them up? Nah, probably whoever's not listening is just, has the screen up to be counted. I'm not taking attendance. I mean, if you are not participating, most likely you're not learning. That's very simple. All right. Well, let's make it worse. Right? But we remember that we need x alone, so I had to add 1 to both sides to kill off this 1 right here. No, it's added to the whole fraction. You can see it here. Mm-hmm. Yep. Awesome. Yep. I am going to move on to another problem just like this one. All right. So same stuff. Different problem, obviously, but the same type. Let's go and have 4y minus 2 y plus 1 equals to 0. The equations. just equations. All of them say solve for and then the variable. Solve for y. They're all equations. That's the only thing we're studying right now. So your job is always to get all of the calculations, to get the variable alone, and that's the solution. So looking at our expression here, what is the first thing we should do? That's extremely close. Distribute -2. That negative belongs to 2, and it will become -2y, and then -2, right? So we start by distributing -2. I'm going to put that together like that, and then go whee. There we go. So 4y minus 2y minus 2 equals to 0. So that negative belongs to 2, and it has to be distributed along with everything else. -2 times +1 is negative times positive is, and 2 times 1 is, so those two became this -2 here. When you multiply things by +1, they don't change, right? So -2, it looks like we just copied it because we were multiplying by +1. Right, cool. Now what? Yes, we call that like terms. We can put the 4y on a pile. So 4y minus 2y becomes 2y. 4 apples minus 2 apples is 2 apples. And then add 2 to each side. And then we divide by 2. Where is the lost part? I need to know so we can talk about it. And then you fixed it, right? We're good. Awesome. So we did simple problems. We did a little bit spicier problems, like a medium spice dish. Should we put one diabolical problem? Yeah, exactly. That's what we want, right? We signed up for it. Problem 44. 6 plus 2x minus 7, close parenthesis, equals 10 minus 3, open parenthesis. I'm not joking. Anything negative you have to say about this problem, please direct it directly to the authors of the book. I'm just the messenger, you know. Actually, no, I don't want to be messenger. Messengers are always first to die. Messengers are always first to die. They say don't shoot the messengers, but then they're all always shot and beheaded and everything else. No, I'm not a messenger. I just read this, okay? What? No, I'm serious. Yeah. Page 106. Problem 44. These guys are not messing around. Do what? Access code for the book is inside my MATLAB. If you did not purchase the physical copy, you have the copy of the book inside the software. All right. So with what? It doesn't matter. You pick. You pick. You pick. Remember, you have to pile up all of the x's, right? So some of you will move left to right, and some of you will move right to left. It's okay. We all have to come up with the same answer. And we'll see what it is. I am going to give you a few more moments to enjoy this bliss. What happened? Well, did you plug the number in and check? Well, did you get 7? No, it's not. So if you got 7, it's wrong. 7 is definitely not the answer. Did anyone get 13 over 2? Okay, good. That's also not the answer. There are infinitely many numbers that I can list. Of course. Perfect. That is the answer. I mean, by looking at this expression, it looks like it should be 27 over 5. So, oh, you just put 27 over 5 and then, yeah, we'll spend some time. All right, let's go part by part here, and remember, you can go back to the YouTube channel and rewatch this at half a speed, rewatch it 15 times. So, even if you don't get something in class, you should ask a question, and then if it's still kind of shaky, you can always go rewatch and, stop by office hours so I'm not all depressed alone, and so on. We are going to distribute positive 2, and over here we're going to distribute negative 3. 6 plus 2x minus 14. Now I'm going to wait for all the face palms on minus 14 where people copied negative 7. Right? So there we go. Now we're going to go with a 10 on this side, and then negative 3x plus 9, because negative 3 times negative 3 is positive 9. Now, at this point, I can work out some numbers here, right? I have 6 and 14, which are like terms, and I can combine them, which would make the problem easier. So how much is 6 minus 14? Negative 8, right? Because 6 and then we take away 14, so we go negative, right? You have $6 and then you spend 14. That means you had to get another $8 somewhere because it's a negative 8, right? All right, on the other side, we have 10 plus 9, 19 minus 3x. Because 10 and 9 are the same type, right? They're both numbers, they're like terms. So we can say 10 plus 9 is 19. Two x is copied. Are we agreeing on that? So if 2x is copied and out of the picture, how much is the remaining 6 minus 14? Negative 8, right? Beautiful. And now, what should we do? We have that situation where we have variables on both sides, numbers on both sides. What is our step? Pile up variables. You can do that by adding 3x. Great. So 5x minus 8 equals to 19. Now what? Yes, sir. And we have okay, got that. Oops. I guess we were right. I mean, I still want to check it just because it's fun. My definition of fun, your definition of fun might have different parameters, but yeah. Distribute, then distribute, like terms, pile up variables, and then get x alone. Once you cannot get x alone if you have multiple x's, so you have to pile up all of the variables on the on one pile, and once you have one variable only in a problem, and that's this step here has only one x, then you can go on and dig to get the x alone to get the solution. Now I still want to check this because I'm awesome, and let's do that. 6 plus 2 times 27 over 5 minus 7 should be equal to 10 minus 3, open parenthesis, 27 over 5 minus 3. Do tell. But that's the same thing. There's no difference between them. There's no difference. The 3 has a minus sign in front of it. Now, when you want to call it a minus or a negative, you have to add 3x to both sides. Yeah, I wish there was, yeah. I really don't know why in English we have negative and minus. Where I come from, there's just minus. Actually, minus. that's the, and I say minus 3, and when I want to say 19 minus 3, I would still say 19 minus 3, right? So there is no difference, negative or subtraction, because when you think about what is technically negative 9, negative 9 is 0 minus 9. It's negative 9. You just don't write a 0. So there is no difference between those, and when you use your eyes and you look at it and you say, oh, minus, use a plus, which is opposite, right? And if it's a plus, use a minus, which is opposite. That's the way I would look at these things. Let's check. This is going to be epic over here. So I need my fractions here, so I can do the common denominator flex. Times 5 times 5, right? So let's see. 6 plus 2, 27 over 5 minus 35 over 5 should be equal to 10 minus 3 times 27 over 5 minus 15 over 5. Why am I not distributing now? Because I'm not solving equation. I'm using now Pemdas, and Pemdas says compute what's in parentheses first, right? So I'm not distributing, I'm not doing any of this stuff that we did earlier for equation, because now the problem is backwards, because I need to compute the value, which means I am going to deal with the values inside parentheses first. So I have my 6 plus 2, and now 27 minus 35 is going to be negative 8 over 5. And on the other side, we have 10 minus 3 times 27 minus 15 is 12 over 5. I don't need these parentheses around fractions because it's 2 times and 3 times, but that's okay, we can leave them. Now it's time to multiply. I'm going to put more fractions in, over 1 and over 1, and multiply across. Still have my 6 plus, because what are my two operations now? It's addition and multiplication. Multiplication before addition, so I have to multiply first. I'm going to get negative 16 over 5, because 2 times 8, right, 16. And on the other side, I get 10 minus 36 over 5. So when you multiply negative 3 times 12, and then you multiply 1 times 5 on the bottom, which is 5. So what do we get? Well, now I have to do fractions again, right? I still have fractions to deal with. So let's go, make those a fraction. So 1 and 1. And make them times 5, because we need common denominator again. So times 5 times 5 times 5 times 5. And we're done. 6 times 5 is 30. Minus 16 over 5 should be the same as 50 minus 36 over 5. 14 over 5 equals 14 over 5. Yes. Same numbers on left and right. So our solution of 27 over 5, your solution of 27 over 5 was perfect. These things get better with practice. So that's what algebra is all about. Working out 100 problems and then one more just to make sure. It looks intimidating when you start, but I want now to make a point here. I'm going to scroll all the way up to the beginning of the lecture. Take a look at our first problem. You see our first problem? And the problem we just did is in the same section. Now, would this lecture be cool if I started with this? Would this lecture be cool if I started with that? And the answer is probably no, right? Because this problem has a lot of things to consider, a lot of calculations to do, where the first one had only 2. And that's where, you practicing and studying gets to play a big role, right? If you do it right or if you do it wrong. You're supposed to start with the simple problems, practice, learn the patterns, and then move on to heavier ones. Not just open any random problem on MyMathLab and immediately expect you will be able to solve it, right? Just like if you go to the gym, I mean, I wouldn't know, but people say, right? You go to the gym and you immediately, put a ton of weights and you try to lift it, right? It doesn't work that way. It's years and years and years of lifting and practicing and lifting, right? Until you get to the point where you can lift big amount of weights that other people can't lift. And everything else in life is like that. You want to learn cooking? Dirt easy, dirt cheap. You pick up simple recipes on YouTube, and then you get into more complicated stuff as you go along. If you want to learn painting, same thing. Draw a square, and get from there, right? Get more complicated and more complicated shapes. So the same for math problems, guys. Do the simplest stuff. Even if you already know it, still do 1 or 2 exercises to kind of get into the mood and review few concepts. And then slowly and gradually increase the heat. And that's what we did here. As we go through these problems, you can see that we started with a single problem. We just subtracted 4, divided -5. Then we had a similar problem, 36, where only 2 things. And then here is 38, increasing the heat, adding 2 z's. We learned 1 step extra to combine z's on both sides, which I said pile them up, pile the variable up, right? And then here is where we introduced the distribution into the mix. So I didn't start with this diabolical problem at the end, right? We broke down all of the skills, and every single problem brought a new skill to the table, and then we combine all of those skills in later problems. Over here you can see distribution, you can see piling up variables in terms of like terms, you can see solving method from the first problem. So this problem here already combined 3 concepts, and then it gets more complicated from there. Now this is probably the most complicated problem they have here by the looks of it. Maybe 48 could be a little bit longer than this one, but that's pretty much it. If you go through the video, if you go through this couple of times and practice similar problems, you will eventually, right, depending on how persistent you are, you will get it, and you will work on it. And if you have additional questions, you will hopefully stop by the office hours right online and ask those questions, and we can go again line by line through each of the expressions and calculations, so you guys can see exactly what. Now, what's important also for office hours is for you to know what to ask, right? That means that you tried the problem, you thought about it, you attempted one way or another way or 3 different ways, and it didn't work out. If you have some work that it's done, we have something to talk about. Otherwise, office hours become a copy of a lecture, me talking, you writing, and in that case, you are not learning anything new. It's not a new experience. It is the same experience in class that obviously didn't work the first time around. So office hours should be different. Office hours should be, you tried homework, you tried problems, and then you got something wrong. You would like to know what's wrong, how it's wrong, how to fix it, right? That's what the office hours are great for. And we go from there. Now there is only one more thing that we need to talk about in lecture 2.2, and then we're going to take a short break before we start 2.3. So the only thing that is left for us in 2.2, and this is very, very short, is to understand that when you have your ax plus b, you can compute the numbers, right, on the here, so I can just put value c. We can compute c if a, b, x are given. So now, in some sense, this is the easiest part of the lecture, and I'm talking about it at the end. So if you have 3x plus 6 equals to this c, and I give you the table of values, here are your x's and here are your c's, and I say let x be negative 2, 0, 1, and 10. Well, your job is to plug these numbers one by one into the linear equation and compute c's. So for x equals negative 2, what should I write? When you plug it in into the equation, what should I write? Okay, so we start 3 times negative 2 plus 6 equals c, and that's going to be negative 6 plus 6, as you said, equals c. So 0 equals c, so the first value here is 0. How about if I plug in 0? What do I get if x is equal to 0? What should I write? 3 times, what's x? 0 plus 6 equals c. How much is 3 times 0? Plus 6 equals c. So how much is c? 6. Okay, plug in 1 for x. So now 1 goes in there. What do we get? Nine. 3 times 1 plus 6 is 3 plus 6, which is 9. And how about if I plug in 10? $36. 3 times 10 is 30. 30 plus 6 is 36. So if you get, you probably will, some of these problems on your homework, all you need to do is to plug the x value in and compute. Now, we will talk more about this when we get to chapter 2, because this is what helps us graph the line, the linear line. So this calculation will be back. And I'm not too concerned about it right now. Yeah, you might have 1 or 2 homework problems on it. I'm more concerned about the stuff we did before. Because this stuff you are going to see again and learn again when we do chapter 3, graphing of linear functions, linear lines. So guys, that's 2.2. I hope you're not disappointed. It was a little bit more interesting than 2.1. We're going, yes. Mm-hmm. Oh no, I picked them. Those are just randomly chosen values that we plug in. Yes? Good. Good. So the pairs are vertical here, right? So that's the pair, that's the pair, that's the pair. So it's like a input and an answer, right? You plug in -2, 0 comes out. You plug in 0, you get 6. You plug in 1, you get 9. Cool? All right. So let's take a couple of minutes break. And when we come back in, let's say, 4 minutes and 17 seconds, we're going to start 2.3, which we're going to actually continue through the next class and finish next class. Are we cool? So see you in now 4 minutes and 2 seconds.